Climate-based daylight modelling with Radiance IES 2. So in the second of these video sessions, I'll now go from the point where we've completed the simulation. So in the previous video, we set the simulation running, but obviously that takes some time. So we stopped the video there, and now we've got to a point where the simulation is complete. So let's go into VE. Okay, so here's our file that we're familiar with, and we've now completed the simulation, so we've got some results. So if we just look down here, you see we've got a results file. Okay. Okay, if I've just clicked on a different room up here. Now we're going to look at this room up at the top here, because this room, we've run the simulation but we've done nothing with it. We've not processed the data yet. So I'll take you, rather than going from a room that we've already processed. One thing to do, once you've completed your simulation, under your dynamic simulation tab, click on your results summary. It's always worth having a quick check here to see what you've actually simulated. So here, for example, we can see location. Now this is set to Emily Moore because it was a project in Bradford. But obviously you'd put the right location in, your working plane height, what your grid is, latitude, longitude. Then number of simulations. CIE overcast sky is 1, because for a daylight factor, for an overcast sky, we only need to do it once because the sky doesn't change. And then simulations for a sunny sky is 148, and the reason for that is because for this simulation, for these results, it was simulated once a month on the 15th of each month. Now I can't remember actually in the video before this whether I'd actually set it running 365 days of the year. I may have done, but anyway, so in the results we've got here, it's for 12 days in the year, and then on each of those days we'll have simulated for every hour during daylight, and that's why we've got 148 simulations. So we've got 12 days, and then on each day, well, it varies throughout the year, obviously, the number of hours per day. But always worth checking here. If you do sometimes get crashes in IES when it's simulating, and obviously you don't sit and watch the screen while it simulates. That'd be very boring. But sometimes you come into your results file and you might have only got 3 months through the year, and then it's stopped. Now that's obviously going to give you very poor results, because you may think you've simulated the whole year and you may have only simulated the first few months. And I have to say, it is quite a poor feature with IES that when the simulation fails, you don't get an error message. So you could proceed thinking that you've got a whole year's worth of data when in fact you may not. So that's certainly one to watch for. So yeah, I mean, I've only simulated 1 day each month. In reality, because your climate data is averaged over a period of days anyway, to be honest, you're not going to find a lot of difference taking the 15th of each month compared with simulating every single day in that month. And it's obviously a lot quicker. Okay, back into IES. So we are in an axonometric view, as you can see at the top here, and we are only displaying story 2. We can display all stories if we wish. It's normally a bit clearer just to see the story that you're interested in. Okay, right, so we've got data. If we look in our working plane grid, we can see we've got a file of results, but we've got nothing to show in the results box, and that's because we need to process the results. So we go back into dynamic simulation and we click down here on process. And we get some options here. So, and you can check more than one. So annual sunlight exposure, and what it will do for the design period, which for this school we'll set that to 8:30 in the morning till 4 o'clock. If you were simulating an office, a workplace, university building, you would choose a different time scale. And for the annual sunlight exposure, what we're looking for is any sensor points on the working plane that are achieving 1000 lux. That's the standard that we're looking for, on the basis that 1000 lux normally means you've got direct sunshine. To be honest, it wouldn't actually necessarily mean that. You could quite possibly, with reflected light, achieve 1000 lux, but generally it means a kind of very bright amount of daylight. And the target that we're using by default is 250 hours in the year, but obviously you can change that if you want. Okay, spatial daylight autonomy, the percent of analysis area that meets the target lux for the target number of hours. Let's check that. And again, analysis period for schools, that is set to 8:30 to 4 o'clock. But as I say, if you were doing an office or a dwelling or any other kind of building, you could change that to suit. Now the 8:30 to 4 o'clock is actually part of the criteria, so it's kind of you have to set it to that for education. If you were working on a building without any kind of specified standards like that, you would choose something sensible. And again, for education, the target is 300 lux, and we want to achieve that for 50% of the hours of the testing period. So 50% of the daylight hours. We're not worried about nighttime, obviously. You can't achieve daylight during the night. We only test 50% of the tested hours. Okay. Useful daylight illuminance. Okay, this allows us to kind of band the performance of our sensors. Analysis period we'll set to the same. Use data roughening, you can do that. I normally just leave it alone, to be honest. Doesn't seem to make a huge amount of difference. Okay, threshold. This one is a little bit confusing. By default, the settings for UDI, for useful daylight illuminance or useful daylight index, are not correct in terms of education design. Slightly odd that the default doesn't really match the criteria that anybody's currently using, but click on edit, we can change that. Now again, I have to say it's a little bit confusing, this. Now we've got a low level, so anything below 100 lux would be classed as low. Well, that makes sense. Anything above 2,500 would be classed as high. That kind of makes sense. But then they've also broken it down into this low, medium, medium to high band. So in other words, low medium would be 100 to 500, and medium to high would be 500 to 250. Now that would be useful information, but to be honest, nobody's really using that at the moment in terms of design standards, so I don't think it's terribly helpful. What we need to do then, we need to get rid of one of these thresholds. So we get rid of the high threshold, and we change our medium to 3000. And again, this now looks a bit confusing because it kind of suggests that we're not interested in our high threshold. But what it will do now, you really have to ignore the words here. We're going to get three bands. We're going to get below 100 lux, we're going to get 100 to 3000 lux, and we're going to get above 3000. It will make sense when you see the results, and really in the software we should be able to rename these bands, but we can't. Okay, click on close. And again, when you look at the thresholds below, because we can't rename these bands, again the name, the actual wording, the description doesn't really make any sense, because it would suggest that autonomous is over 3000, and that's just not right. But it's, as far as I'm aware, it's the only way to process the results in IES to make sense in terms of the education criteria. I'm sure they'll change it, but that's how it is at the minute. Okay, click on OK, and you always get this little warning message and a beep, which I don't know why it does that, but telling that you need to go to WP Grid to view the data. Okay, so here's WP Grid tab. Click on that, and now you can see that we have now got this post-processing of our results. So a little bit confusing, but the thing to bear in mind is, with the climate-based daylight modeling, we will be getting thousands of results, because we had, what did we have? We had 144 different times in the year, but then we maybe have got 100 sensor points. So we've already got about 144,000 individual illuminance readings for each of those points, for each of the hours that we tested. If you then tested for the whole year, then you've got more. You've got 365 days. You might have on average 12 hours per day, and then you might have 100 sensor points. So clearly it's a lot of data. And what the results do here is they simply group that data and try and make some sense of it for you. Okay, and I think the easiest thing to do is just to have a look at it and try and understand it. So let's go, first of all, let's go into one that we know. So let's click on the daylight factor for overcast sky. We know what we know about daylight factor. Nothing seems to have happened. Okay, nothing's obviously changed on screen. What you need to do in IES, you need to click on this move down button, move down a level. That takes you to the level of the room, and it shows us some results. Generally, change it into the plan view, and that will be a lot clearer. That will make a lot more sense, hopefully. So what we've now got, we've got a view of our room. It's color coded, and this one is daylight factor. Just going to zoom out a bit there, and there's your color code on the right for your daylight factor. But if we come down to the bottom right here, under the working plane grid, statistics, click on draw statistics, then we get on screen some slightly more meaningful statistics here. So daylight factor for overcast sky, and some of the percentages and the ranges that we're getting. So what we can see is our average daylight factor is 1.78. So that's a mean average of all the points. The percentage of points that are over the 2% is 24.58%. Okay, so indicating that this room is actually not performing terribly well, which is not very surprising. If we go back to the axonometric and have a quick look at the room, you can see we've only actually got this one window on a very long room. If we go back into the plan view, you can see that our daylight factors at the back of the room are actually very, very low here. Okay. Okay, so what I'm going to do, I'll stop the video there, and what What I'll do is in the next video we'll go through and we'll look at all the other kinds of results that we've processed.